Chapter 8 is all about factoring, which is breaking things down. So we're going to start by reviewing prime factorization and finding greatest common factor. So, first up is prime factorization. And we're going to factor 60. We're going to do it first with a factor tree. So what we need are two numbers that multiply together to make 60. Any two numbers will do. The first two that probably spring to mind are 6 and 10. Since neither one of those is prime, we have to break them apart. 6 is 2 times 3. 10 is 2 times 5. 2, 3, 2, and 5 are all prime numbers, which means we have factored 60 completely. If we were to write this in its exponent form, it would be 2 squared times 3 times 5. 2 squared because there are two 2's. The latter method asks you to say, okay, give me a prime number that we can divide out of 60. For example, 5 is prime, and 60 divided by 5 is 12. Now give me a prime number that can come out of 12. That is 3. 12 divided by 3 is 4. Give me a prime number that divides into 4. That is 2, and it leaves 2. There's my 2, 2, 3, 5 like I had before. Just a slightly different way of doing it. These numbers, you can use whatever method you like. When I see 40, I'm thinking 2 and 20. 20 is 2 and 10. 10 is 2 and 5. So that is 2 cubed times 5. 33 is 3 times 11. And that's all you can do with that. 3 and 11 are both prime. 49 is 7 times 7. So that's 7 squared. And 19 is prime. We can't break it down anymore. The greatest common factor of each pair. Now, this is where I like the ladder. And you may hear my dog whining in the background. I think she saw a squirrel. So here's how this works. I'm going to write down the two numbers. I'm going to say, give me a number, any number, that divides into both 24 and 60. For example, 12. 12 divides into both 24 and 60. 12 divided by 24 is 2. 60 divided by 12 is 5. There are no common terms that come out of 2 and 5. As a matter of fact, they are both prime. So, the GCF is 12. It's that number on the left side. Okay. We got it the first time here. And no, I didn't do that intentionally. I just picked 12. Let me show you how that would work if I didn't immediately get the LC, or the greatest common factor. So 18 and 27. So let's say we looked at these and said, hey, I can divide them both by 3. 18 divided by 3 is 6. 27 divided by 3 is 9. We look at these two numbers, 6 and 9, and say, hey, I can divide those both by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And now 2 and 3 are what we call relatively prime. They don't simplify any further. Here, the GCF is now 3 times 3. The two numbers over here on the left. The two numbers on the outside. So the GCF is 9. We're going to be taking this idea of a GCF and expanding it to include variables now. What? Why? Okay, so apparently I'm not allowed to write down here. I don't know why. Let me do that. That should fix the problem. Looks like it did. Okay, so let's try that again. 3x cubed, 6x squared. Well, what can come out of 3 and 6? I would hope you're all shouting 3, or at least thinking 3. 3 divided by 3, of course, is 1. 6 divided by 3 is 2. When we talk about x cubed and x squared, and we're just going to do a little sidebar down here. When we talk about x cubed and x squared, that's really x times x times x and x times x, which means this bit right here they have in common. They share x times x, which means x squared is common. If I take x squared away from x cubed, and look right here for this, if I take x squared away from x cubed, there's just this single x left. And when I take x squared away from x squared, there's nothing left. What this is showing us is the GCF, the greatest common factor of these two things, is 3x squared. And when we factor 3x squared out, we're left with x and 2 respectively. That'll come in handy later. And the last example here, we have 4x squared and 5y cubed. So numerically, 4 and 5 don't factor. They are relatively prime, meaning nothing comes out of both of them. And x squared and y cubed don't play nice with each other because they're not even the same letter. That means the greatest common factor is 1. We do have to recall there's no such thing as no greatest common factor. But if we can't figure one out, everything has a common factor of at least 1.